Lecture. I am Dr. A.VELMURUGAN, Assistant Professor, Department of Mechanical Engineering, Government College of Engineering, Chettikare, Dharmaburi. In this video lecture from upcoming semester Thermal Engineering 2, Unit 5, Refrigeration and Air Conditioning System. From Module 3, we have discussed about the Vapor Absorption System. Previously, we have discussed about the Module 1, Introduction about the Refrigeration Cycle. Module 2, we have discussed about the vapor compression system. From module 3 we have discussed about the vapor absorption system. From the vapor absorption system is generally used for that various application and also using for the large unit sector, because of the floating peoples are used from that, particularly from the bus stand or railway station. We need more number of water, we have to cooling the water, so that purpose we have to using this vapor absorption system. From the vapor absorption system, these are all the important components are useful. That is a evaporator, absorber, generator, water separator or reheater or condenser. From this process, that is a, from here we have discussed about the three liquid process. One is a water, ammonia and hydrogen gases used for this type of vapor absorption system. Next slide we have discussed about the introduction. The vapor absorption refrigeration system is one of the oldest method to producing refrigerating effect. The principles of vapor absorption was first discovered by Michael Faraday in the year of 1824. The first vapor absorption refrigeration machine was developed by the French scientist Ferdinand Care in the year of 1860. In this system, the ammonia is used as the refrigerant and water is used as a absorbent. From the comparison of vapor absorption system with vapor compression system, from this absorption system it is differs fundamentally from the vapor compression system only in this method of employed for compressing the refrigerant. In this absorption system, from that there is a compressor is replaced with, from the place of compressor, absorber, generator and pump. From that vapor absorption system uses heat energy instead of mechanical energy, as in the vapor compression system, in order to change the condition of the refrigerant for the operation of the refrigeration cycle. The major drawback of the vapor compression refrigeration system is that requires large volume of refrigerant vapor, which requires large mechanical power for its operation. From the principle of vapor absorption system, there is a peculiar property of some substance to have affinity for another substance at some temperature and pressure condition and less affinity to another condition. This idea for the working principle of vapor absorption system was generated by Michael Faraday in the year of 1824. He knew the silver chloride AgCl from that white powder had a property to absorbing the large amount of ammonia gases at the normal temperature and pressure. From this, from that section, from that unit, there is a two chamber for combined with help of tube. The white powder was kept inside the first chamber, to which ammonia gas was supplied and sealed. The powder was heated up while the other end was cooled using the circulator water. This liquid ammonia was obtained in the cool end of the apparatus. After stopping the heat, it was observed that liquid ammonia, instead of sitting there, started the boiling. The bubbles are produced, the vapors are reabsorbed by the white powder. Upon the touching the boiling end, it was astonished to find the vessel was very cooled. He repeated the experiment, was cooling was absorbed again. This led to invention of the intermediate vapor absorption system having the solid as an absorber. From this figure we have to clearly mention for the Faraday, from that intermediate vapor absorption system, from that from that vessel we have to fill the powder AgCl with the help of the burner or mandrel to heat at the powder. That the powder will be goes to the from the pipeline. From here we have to insert the ammonia gas supply from the sealed tank. That ammonia gas and the powder will be mixing. That gas is going to the from that another tank, from the cooling tank, from with the help of the water. That water will be absorbed. This chamber will be filled with liquid ammonia. After it will be evaporating, that powder will be absorbed, it goes to the original direction. From this process we get the chilling effect from this liquid ammonia from that cooling tank. Next slide, we have discussed about the simple vapor absorption system. From the simple vapor absorption system is generally used for the various application. From this simple vapor absorption system, these are all the important components: evaporator, absorber, generator, rectifier or dehydrator, condenser and receiver. From that variable compression refrigeration system, we have to using for compressor from here, but we have to using for evaporator, receiver and condenser used for the VCR system. But in the vapor absorption system, we have to using for absorber, generator and rectifier or dehydrator and pump. From that vapor absorption system, generally that is from the after expansion process, from the expansion valve, from that the liquid refrigerant is, that is a ammonia liquid is entered to the evaporator. There is a heat will be absorbed from the place of refrigerator. From that phase changes from that liquid, it will be goes to the vapor. From that we get the chilling effect from the surroundings. We have to get the chilling effect and the cooler temperature from that evaporator. After that vapor is goes to the absorber. From that they show from the green line because of low temperature. From that observer, that is a from that observer there will be water is present from that place of observer section. From here there is a coolant water is used. From that then the vapor is reaches observer, where it is readily absorbed from the temperature, from that cooling medium, from that water. So generally from that ammonia and water is easily it will be quenching. So from that condition the heat will be automatically rejected. After that the ammonia it become the very strong solution. That strong solution is with the help of the pump is merged with the heat exchanger. Again it goes to the generator section. From that generation section, if we have with the help of that heating coil to heat the strong solution, if we have any amount of ammonia from that weak solution, means again with the help, again with this it goes to the observer. From that weak solution is goes to the observer with the help of the pressure reducing valve. From here we have to using for that heat exchanger is used for that heater this strong solution. After the strong solution is goes to the prepared to the high pressure and passes through the heat exchanger. Here that takes some heat from the weak solution, which is throttled to entering the back of the observer. It increase the efficiency of the system. If the weak solution is entered to the observer, means it will be increasing the efficiency of the system. Generally that ammonia is acting on the minus 42 degrees Celsius, so easily it is absorbed from that separate from here. We have to separate the ammonia and water from the section of generator. As a generator to heat the strong solution, therefore forming of the ammonia vapor. Here some of this water may also vaporized. This water vapor is separated in this analyzer. Even after this, if the any water vapor is present, it will be exchanged. It goes to the rectifier by passing the cooling water. From this section is a rectifier, that with the help of the cooling water to vaporize that water, that is water will be vaporized from this section of rectifier or dehydrator. After that solution is going to the condenser. From that condenser with the we have to using the cooling water. Generally I told about you the condenser is a heat exchanger process. After that the ammonia vapor is entered to the condenser, the cooling water is passed through the condenser. Because the condensation process, the refrigerant vapor becomes the liquid refrigerant. That liquid refrigerant is goes to the receiver. After that expansion valve, that again the solution is goes to the evaporator. This process is repeatedly we get the chilling effect. Generally the simple vapor absorption system is used for the railway station or bus stand. Because of the we need more number of water, cooling water is required for this floating section. So that condition, that vapor absorption system is generally used for the 0 degree Celsius, but it is not possible to minus degree. That is from the simple vapor absorption is used for only the 0 degree Celsius. We have to cool the water for the mass applications. From the major advantages for that system is the vapor absorption system. Here we have to show the figure, that is a vapor absorption system. From the blue color line is show from the ammonia gases. After the green color line is ammonia and water solution is mixed, and blue color line is navy blue, and dark blue line is ammonia liquid. That another refrigeration is used for the domestic Electrolux refrigerator. From that domestic absorption type refrigeration was invented to Swedish engineers Karl Munters and Balthasar von Planten in the year of 1925. This type of refrigerant is also called as a three fluid absorption system. From this absorption system, we have to using for three fluids. One is a water, another one is ammonia, another one is a hydrogen. From the main purpose of the system is to eliminate the pump. From this system, we have to eliminate the pump. From the vapor absorption system, we have to using the pump. With the help of the pump, the strong solution is going to the generator. From this system, we need not record to the pump, so that the options of moving parts from this machine, because of it is a noiseless. From here, the three fluids are used. System is water, ammonia and hydrogen. The system cannot be used for the industrial purpose, as the COP of the system is very low. From that figure, we have discussed about the ammonia hydrogen electrolux refrigeration system. From here already, as I told about yearly, there is a three liquids: water, hydrogen and ammonia. From that liquid ammonia is entered to the evaporator, we get the chilling effect from the surrounding. After that liquid, after that from that liquid is goes to with the help of ammonia and hydrogen. After that, from that observer, there will be water is present. From that water is easily soluble for that from that ammonia and hydrogen. After it goes to the strong solution from the heat exchanger, it is goes to the generator. From the generator with the help of the burner. But in the vapor absorption system, we need record for the pump. If using the pump means there will be more noise, but here we have to with the help of the gas burner. Depending upon the temperature distribution, that the strong solution is easily moved to the generator section. With the help of the burner, that the strong solution is good. After that, from here some amount of weak solution ammonia is present, means again it is recirculated to the observer, goes to the observer. From that generator, the solution is with the help of the rectifier. If you have any water vapor or present on the rectifier, means so easily the vapor is evaporated. After that, the ammonia vapor is goes to the condenser. After that condenser, that from the heat exchanging process, the ammonia is formed. From the ammonia vapor is changed from the liquid ammonia. That liquid ammonia goes to the evaporator. Again we get the chilling effect. From that electrolysis refrigeration system, that we have to using the three liquids: water, ammonia and hydrogen. Next slide, we have discussed about the advantages of the vapor absorption system. As there is a no moving parts in the system, the operation is quiet and there is very little wearing. From that vapor absorption system, there is some moving parts. That's why we have to get the very little wearing. And the vapor absorption system uses heat energy to change the condition of the refrigerant from the evaporator, whereas the vapor compression uses the mechanical energy to change the condition of the refrigerant. From that vapor absorption system, the working capacity is above 1000 ton. That can be operated from the designed COP, and even the pods are varying the generator temperature. And also it is used for the space and auto control requirements are favor for the absorption system. Major disadvantage of the vapor absorption system is from the VCR refrigeration system, the efficiency is high, but in the vapor absorption system, the efficiency is very low. It take long time to produce cooling effect. And also here we have to using the fuel too. From the generator application, kerosene, oil or gas flame gives the bad smell. Due to the low working pressure, the COP of the vapor refrigeration is very low. The initial cost of the equipment is very high. It is come from the compared to the practical absorption system. Thank you.